Okay, let's talk a little bit about pH. On the previous video, we had mentioned that acidic solutions have pHs below 7 and basic solutions have pHs above 7. And also a pH with a solution with a pH of 7 is considered neutral. Today we're going to learn how to actually apply some mathematics to this concept. We're going to learn how to calculate pH. You can think of pH as simply an expression of the hydrogen ion concentration of a solution. You'll see on the bottom left-hand corner of the screen here that I have this equation that pH equals a negative logarithm of the H plus concentration. A couple things to point out here. In chemistry, if you ever see brackets surrounding something like you can see in this formula, you read that as concentration of whatever's in the brackets. So two brackets around H plus, you read that as the concentration of H plus or the concentration of the hydrogen ions. It's also important to notice that this formula does have a negative in front of the logarithm. So it's the negative logarithm of H plus. Now, if you don't have H plus, you're going to either have to calculate it or determine a method to get that value. But some of the examples we're going to look at first, the value of H plus will just be given to you. So let's start with just some really simple examples. So let me get rid of this highlighter mark here. Okay. So this first question here, it says, what is the pH of a solution whose hydrogen ion concentration is 1 times 10 to the negative 5th molar? One thing that I like to do in this is sometimes if I'm not a big fan of having to punch in this number into my calculator in scientific notation, I might actually switch it to standard form. So I've rewritten this as 0.00001 here on the underneath the original number. And that'll just make it a little bit easier for me to put this in my calculator. So if I use my on-screen calculator here, and let's minimize this a little bit, you can see that some calculators you will have to hit the log button first, and other calculators you'll have to put the number in first. This particular one I have to put the number in first. So I will type in the number in standard form like it was below, and I will hit the logarithm button. When I do that, I get negative 5, but remember I was supposed to have taken the negative logarithm. So if I hit the little negative button, I see that my answer is 5. So the pH of this solution is 5. What does this tell us? Well, from the previous video, we learned that anything under 7 is acidic. So whatever this solution is, it happens to be an acidic solution. Let's look at another example. So in this example, it says, what is the pH of a solution with a hydrogen ion concentration of 7.8 times 10 to the negative 7th? So once again, I switched this number up from scientific notation to standard form. So I've rewritten it. It has 7 zeros before the 7 and 8. And again, what I can do is just simply plug this into my calculator. So I'll take 0.0000000. So I've got 7 zeros here, 1, 2, 3, 4, 5, 6, 7, yep. And then I'll hit 78, and I'll take the negative logarithm of this. Now, once again, this comes out as a negative number, but it's because I didn't take the negative logarithm. So I'll hit the little plus minus button here on the bottom of the calculator, and it switches it to about 7.1 as the pH. So looking at this one, oh, I wonder why that's different than what I had. That is because I should have only had 6 zeros. So let's recalculate that. This number actually should only be 6 zeros instead of 7. So we redo that, 0.0000000. 7, 8, 6 zeros. Take the logarithm, hit the negative sign, 6.1. So that matches the number that was hidden here. This basically highlights a pretty important point here, is that you have to count your zeros very carefully because you can see that it'll completely throw off the pH. Now this value of 6.11, that's an acidic pH. So anything below 7 again is acidic. So this solution again is an acidic solution. Let's look at pOH. So pOH is almost identical to pH, except it's the negative logarithm of the hydroxide ion concentration. So the formula almost looks identical, except for in brackets here, I've got OH minus. So how do you calculate it? Again, all you have to do is take the negative logarithm of the hydroxide ion concentration. If you're given this value, you simply plug it into your calculator. If you're not given this value, you might have to do some extra steps to get it. But let's look at a really simple example for it. So here we have a question that says, what is the pH of a solution with a hydroxide ion concentration of 4.2 times 10 to the negative 10th molar? So again, we could plug this into our calculator pretty easily. This time I will have 9 zeros, so I would have 0.0000000. So again, you've got to be careful when you punch in all of these zeros, because if you miss one or add an extra one, it's going to mess up your answer entirely. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Then I hit 4, 2. And I'm going to hit the log button. And again, it comes out negative, but I hit the little negative, positive, negative sign, make it negative. And I've got 9.37 or 9.38. So I can move this. Now, the pOH is 9.38. So a lot of people would say, okay, so it's a basic solution. Not quite. Remember, if it's above 7 and it's if the pH is above 7, it's basic, but this is not the pH. This is the pOH, and it is different. So right now, we really don't know how to label this solution. We just know how to calculate the pOH. There's actually another equation how you can get the pH from the pOH. So don't assume if you look at this, you can't say, oh yeah, the pOH is above 7, it's automatically a base. Not quite how that works. So let's look at this next slide. This is the key to the last problem here. So if we actually see, if we actually look at this one, we can see that pH plus pOH is 14. So if we go back, this particular one, we can see that, let's take this answer here, copy it, and we'll paste it into the slide. Make this a little bit smaller so we can actually see. So let's say on the previous example, we wanted to know if it was an acid or a base. Well, let's look at this. We know that the pOH is 9.38, and we know that 9.38 plus pH equals 14. So if we get our calculator out again, and we punch in some of these numbers here, so we will take basically 14 minus 9.38. We can see that in the previous problem, the pH was actually 4.62. So the last one with this pOH and a pH of 4.32, that would actually have been an acidic compound. So you have to be very careful. It's pretty simple to use, though. You just have to know how to plug it in your calculator and realize that pH plus pOH equals 14. Let's say you get into a bind and you're really wanting to calculate pH. So you really need to calculate the pH, but there's a problem. You actually do not have the H+. And we know that you have to have the H+ because the negative log of H+ gives you pH. But the only thing the problem gives you is the OH-. Well, what you can do is actually use this bottom formula here, and you'll see that H+, the product of H+ and OH- is actually equal to a constant number here, this 1.0 times 10 to the negative 14th. So there's several steps to doing this properly. Just remember that you'll need to be able to utilize these three equations. So we've got the pH plus pOH equals 14. We've got H plus times OH minus equals 1.0 times 10 to the negative 14th. And at the very beginning, we talked about pH equals the negative logarithm of H plus. And then our other equation was pOH equals a negative logarithm of OH minus. So this is basically 4 different equations you can utilize to either calculate pH, pOH, OH minus, or even H plus if needed. So hopefully this is helpful as you go through different question types where you've got to calculate these different quantities.